All right. Hello. Hope you're doing good. Going to talk a little bit about Project 9 today as part of the ECEG 431 course. So kind of as you know, where we are in the course, we have now created a 16-bit computer. We've now been working on translating code from a VM language that can run on that computer. And now the next step is going to be to translate the high-level code that we write into the VM code. So to do that first, we want to then start playing around with what this high-level code looks like. And this is an introduction to the Jack language. Then coming up, we'll work the Jack compiler and then deal with some system service level items such as the book calls it the operating system. As we saw in class today, let's look at the Jack code, what that looks like. So in this case, we have a main class that instantiates some points, and we also have a point class that is now the implementation of that abstraction that is the point. This is a language that's very similar to Java. It is object-oriented, and everything is a class. We have instance of classes. It's, of course, a multi-purpose, general-purpose language, and it very much lends itself into interactive apps. If you have any programming experience with other object-oriented or other languages, it's very quick to learn. So object-oriented languages allow us to start abstracting away concepts into objects so we can reuse those. And we have the idea about the abstraction and then the implementation. Much like what this course has done, we have the interface that kind of like leads into some underlying mess of things, and we have what the abstraction of how that operates. For instance, the VM, the virtual machine, it's all these little tiny commands that have 20 assembly commands underneath that, but we just know that pop memory 5, whatever, will pop through that to a certain memory location. Okay, so with that, I'd like to go over just a simple Hello World example. This is a Jack program that starts with Hello World. We can see we have several items. We have comments, we have some functions, we have variables, we have return statements. But the effect of running this is that we print Hello World to the screen. So the language constructs. First of all, we see we have comments. There's going to be 3 types of comments. We have an API block comment, which is used for documenting, documenting our implementation. We have full line comments that are really, I guess, are block comments. We can block out anything between a /* and a */ that can be multi-line. And we, of course, have end-of-line comments like we've handled before. White space in the Jack language is also going to be ignored. So unlike Python, the white space does not convey. So in terms of reading Jack code, it, of course, is procedural in the sense that we go line by line. So in this case, we're going to compute some numbers and get their average. So here we see the code running. How many numbers do you want? Enter the numbers, and we compute the average, print that out. So to do this in code, we know that we're going to need some numbers. We're going to then interact with the screen, get user input, compute an average. So I'm creating an array called A. It's a variable, so I'll start with the name bar. I'm also going to have some other integers, length, I, sum. I assign to the variable length the input from the user. So this is going to be using a system level function. So we use the keyboard, read integer, give them the prompt, how many numbers. Types in the number 3, and we assign that to the number length. I then create the variable A to be a new array. So array is in itself an object that you're using. And I give it the length to be whatever the variable that the user types in. That constructs the array, and it returns in a pointer or reference to that object. That's what A is. Then we enter our loop. While our temporary variable I is less than the length the user entered, we're going to ask the user to enter a number. We assign that into our array. Again, much like any other language, we can simply use array-based indexing. We then add that to the sum, and then we increment our variable counter I. And at the very end, after we've received all the numbers, we then compute the average and display that to the user. There we go. That's the procedural nature of some code that we are using. So in this language, a few of the constructs. We're going to make programs that are a collection of one or more Jack classes. Each class is going to be its own file, kind of like MATLAB in that. So one of your Jack programs must be the main class, and that must implement a function called main. the entry point. When the system boots up and begins running code, it's going to search for the function main.main and begin running code. So this is our entry point. We jump in, and now we're going to make some variables. So here we see 3 variable types, but Jack has ints, chars for characters, and then Boolean data types. We also have class types. So the OS provides several of these, such as array and string. And additional, any other abstract data type can be defined and used as you want. That's part of your job as the developer. We assign some variables, get some user input, but then we also have flow control. We have if else, while loops, while loops. Do allows us to call a function. And then we can assign various things. This is using arrays. So the array is implemented as a part of the standard class library. We'll develop that in Project 12. And then these arrays themselves are not typed. In essence, they're a linked list. The OS is also providing other services I mentioned. We can read from the keyboard an integer. We can print a string to the output. We can print an integer, depending on what we want to do. For example, of using this code. All right, I'm going to stop it there, and we'll jump into object-based programming in the next video.